Hi everyone, myself Dr. K. Srinivas Rao, working as a professor in the Department of CSC AML department at G. Pullareddy Engineering College, Kurnool. So in this video, we'll discuss about inter-process communication IPC and what are the types of IPC. And in this video, we'll discuss one of the technique shared memory. In the next video, we'll discuss about the another one, that is message passing. So first we'll see what is meant by process communication IPC. So depending on the nature, we have the two types of processes. One is the independent processes and second one is cooperating processes. The independent processes is nothing but one process is independent of another. It is nothing but a process which cannot be affected by another process, then these two processes are said to be independent processes. And the cooperating processes is nothing but dependent. It means a process is cooperating or depending on another process, then those two are said to be cooperating. It is nothing but a process can be affected by another process, then these two processes are said to be cooperating processes. And here we'll discuss about the cooperating processes. So one is affected by the another process is nothing but some communication to be done between the two processes. When there is a communication, then automatically some data can be transferred between those two processes. So here we'll see what are the advantages of cooperating processes. Why the uh, communication is required between the two processes. Advantages of cooperating processes. The first one is information sharing. If the two processes are cooperating processes, then automatically the data or the information can be shared between two or more number of the processes. And computational speed up, it is nothing but the time required for execution of a process can be reduced. It is nothing but within the less time we can complete the execution of a process automatically. And the third one is modularity. It is nothing but, for example, there is a large program or there is a project, and that large program or project can be divided into different number of the module. If the large program is executed by only one person, then automatically it will take more time for execution. So that's why if there is a large program, then it is better to divide that large program into some number of the module, and then each module is executed by another one process, and finally after completion of the execution of all the processes, then all the intermediate results can be combined together to get the final result. So that's why the cooperating process, the communication is required between the processes. Modularity, the total large program can be divided into multiple modules and can be executed separately. And the last one is very convenient for the usage. So these are the some of the advantages of cooperating processes. And these cooperating processes needs inter-process communication, that is IPC, inter-process communication. So there are two models of IPC. One is the shared memory and second one is the message passing. So in this video, we'll discuss about shared memory. So first we'll see the basic definition of these two models, and then we'll discuss about shared memory. Okay. So see the diagram here, shared memory. So this is the total memory. Okay. And one part of the main memory we can reserve it for the operating system, for the kernel, and remaining part, the all the data or all the processes can be stored in the main memory. If you see this diagram, there are two processes A and B. Two processes A and B are there, and process A wants to send the data to B. So there should be some communication between A and B. The data to be transferred from process A to process B. So in the case of shared memory, how the communication can be done is as follows. Whatever the data A wants to send, process A wants to send, so that data is placed in the shared memory. Why we are calling this part of the memory as a shared memory? Because this part of the memory can be shared by all types of processes. So that's why we can call this part of the memory as a shared memory. So the process A will place the data in the shared memory, and then process B can read the data from the shared memory. So first A will place the data to shared memory, and from that shared memory process B can read the data. It is nothing but indirectly the process A is sending the data to process B via shared memory. Okay, so this is called shared memory. And see the second technique of IPC, that is message passing. So in this message passing, same as this previous one, here also one part of the memory we can give it for the operating system, and remaining we can use it for the all the processes. Okay, so here also we have taken the two processes A and B, and process A wants to send the data to process B. So whatever the data A wants to send to B, that data is placed in the form of the message. It means process A will create the message, and that message contains the data to be transferred to process B, and that message is placed in the message queue. So each message having the data to be sent to the process B. After sending the message, then process B can read the message. After reading the message, it is nothing but the process B can receive the data sent by the process A. It is nothing but A and B processes can communicate to each other by exchanging the messages. By passing the messages, these two processes can communicate with each other. So that's why this communication technique is called as message passing. So in the next video, we'll discuss about the message passing, but here we'll discuss about the first one, that is shared memory. So see the main point, shared memory system. Before discussing the concept of the cooperating processes, first we'll see one problem related to this one, that is a producer consumer problem. So here in this problem, producer and consumer both are separate processes. These are processes. Producer is one process and consumer is another process. So the role of the producer and consumer is, a producer is the process which produces the data. So producer can produce the data. It is nothing but it can write the data. Producer can produce the data, write operation. Whereas the consumer is a process which can consume the data which is produced by the producer. It is nothing but consumer can do which operation? Read operation. So producer can produce the data, whereas the consumer can consume the data. So these two, producer, consumer. For example, see here the main point, producer process produces the information and which is consumed by the consumer process. Okay, for example, if there is only one buffer, there is only one buffer. Within that buffer, if one item was placed, only one item can be stored. If there is only one item, so see here, there is a producer and a consumer. When producer is producing the data, then at the same time, the consumer cannot consume the data. Why the consumer cannot consume the data? Because producer has not yet completed producing the data. So after completion of producing the data only, the consumer can consume the data from the buffer. So one by one only the producer and consumer processes can do the execution. If both producer and consumer wants to execute at the same time, then we can have a problem called producer-consumer problem. So at a time, these two cannot be executed concurrently. So that is called producer-consumer problem. And to allow this concurrent execution, it means if want to execute both producer and consumer processes at the same time, so instead of taking a single buffer, we can take a buffer of item. We can take a buffer of item. It is nothing but, see here, there are three buffer of items. There is one process and a consumer. So initially, producer is producing the one data and producer is producing the second data. When producer is producing that second data, then at the same time, the consumer can consume the first data. So similarly, when the producer is producing the third data, at the same time, the consumer can consume the second data. It means both producer and consumer processes can be executed concurrently at the same time. So a producer is producing one item, then at the same time a consumer can consume another item. So by using a buffer of items, what we can do, both producer and consumer processes can execute concurrently. So there are two types of the buffers here. One is a unbounded buffer and second one is the bounded buffer. So unbounded buffer is nothing but there is no limit on the size of the buffer. There is no particular limit on the size of the buffer. And whereas in the bounded buffer is nothing but there is a fixed size for the buffer. Buffer size was fixed. But whereas in the unbounded buffer, there is no limit on the size. If the buffer is unbounded buffer, then what will happen here? Always the producer can produce one item. So producer never waits because there is no limit on the size of the buffer. So always it can produce any item. Always it can produce the item. So it will not in the waiting state at any time. So producer never waits. But a consumer can wait if there is no buffer to consume. If there is no item to consume, then at that time consumer has to wait. Whereas in the unbounded buffer, producer never waits, but the consumer has to wait. When it will wait consumer? If there is no buffer to consume. And similarly, in bounded buffer, there is a fixed size buffer. So here in the second type, the producer will wait. When it will wait, if all the buffers are full. For example, if the buffers, three buffers are there and there are three items, 1, 2, 3. So producer has produced 3 because what is the size of the buffer here? We have taken 3. So already the producer has produced 3 data. Then at the same time, when the producer wants to produce the fourth item, it will be wait until the consumer can consume one of the item. So producer must wait if all the buffers are full. And consumer waits if there is no buffer to consume. So producer will wait if all are full and consumer is also wait when it will wait if there is no buffer to consume, means all the buffers are empty. So these are the two types of buffers, unbounded buffer and bounded buffer. And here we'll see the structure for producer and consumer process. Before discussing the structure and consumer process, we'll see what are the variables we have used in that structure. So the first variable we are taking in variable. So this variable in points to the next free position. It means see this example, this is the 3 buffer here, producer and consumer. So 1, 2, 3 for example. So where this producer can produce the data initially at the first position, it can produce the data. After that, the producer can produce the second data in the second one. So this in value is incremented by 1. So here the second data will be produced, and the producer can produce the third item in the next free location. This is the next free location. So here it can produce the third data. So the variable in points to next free position in the buffer. Next, the variable out points to, so see here already 3 data present, producer and this is the consumer. First, the consumer can consume which data? It can consume A, and then it can consume B, and then it can consume C. So consumer can consume the data from which position? From the first full position. After that, next full position. After that, next full position. So that the variable out points to first full position in the buffer. So these two variables we are using in the structure of the producer and consumer process. Next, before discussing the structure, here see the two condition. The buffer is empty. Before consuming the data, what is the condition? At least one data should be present in the buffer. If there is no data, means if the buffer is empty, then consumer cannot consume the data. So before consuming the data, first we have to check whether the buffer is empty or not. If the buffer is empty, then consumer cannot consume the data because there is no data to be read. Similarly, for the producer process, the buffer is empty. If the buffer is full, then the producer cannot produce the data. So before producing the data, first it has to check whether the buffer is full or not. If the buffer is full, then producer cannot produce the data. If the buffer is not full, then it can produce the data. So these conditions we have to check. So the condition, the buffer is empty, we can write it as in equal to out. And buffer is full means in plus 1 by buffer size equal to out. So these condition we have to check for the consumer, and this condition we have to check for the producer process. Okay. The next we'll see the structure for the producer process. Here we have taken some item to be produced, while true, and here we are writing the code for the producer process. So what condition we have to check for the producer process? Whether the buffer is full or not. If the buffer is full, then producer cannot produce the data, otherwise it can produce the data. So for checking whether it is full or not, we are using the condition while in plus 1 by buffer size equal to out. If this condition is true, it means buffer is full. If the buffer is full, we have the semicolon, it means nothing will be done. So the process will be terminated because the buffer is full. There is no empty space to produce the data. So the producer process will be terminated. If it is not equal to out, then the buffer is empty. Buffer means empty means at least one buffer was empty. So within that empty buffer, the producer can produce the item. So in the in position where the producer can produce a empty position, so the item can be produced in the in location at which buffer. Item will be produced in the in location at buffer, and after producing the item, the in value will be incremented by 1. So because here we have taken the location 1, 2, 3, producer and consumer. So initially producer in value equal to 1. So what is the first empty position here? 1. So after producing A in the first position, where the producer can produce the second data in the second location. So how we can get this second location? By incrementing this one value by 1. So in equal to 1 plus 1. 1 means in. So in plus 1. and after this 1 plus 1 equal to 2. So within this second location it can produce. Again this IN value will be incremented by 1. So 2 plus 1 equal to 3. So producer can produce the data in the third location C. So like that, after producing one item, the IN value will be incremented by 1. This is the code for producer process, and this is the code for consumer process. So here we have taken the data consumed here item while true, and for the consumer process the condition is the buffer should not be uh, empty. If the buffer is empty, then the consumer cannot consume the data because the buffer was empty. There is no data to be read. So the buffer was empty, so consumer cannot consume the data. So first you have to check the condition whether the buffer is empty or not. So how we can check whether the buffer is empty or not with the help of IN equal to out. If IN equal to out, so see this one 1 2 3. Okay, what is the value of IN here? 1, first full position, and out means empty position 1. Both are same, 1 1. In equal to out. In equal to out means the buffer is empty. If the buffer is empty, then no data to be read. So consumer cannot consume the data. So the execution of the consumer process will be terminated, semicolon. Otherwise, if IN not equal to out, if IN not equal to out, then we can consume the data from which location? Out location, from the buffer. We can consume the data from the out location, from the buffer. After consuming one item, automatically the out value will be incremented by 1. So this is the code for consumer process. So these two are one type of the code, and we'll see another type of the code for producer and consumer process. In this second type, we are using the variable called counter. Counter variable we are using, and this counter variable contains how many number of full buffers. It stores the number of full buffers. How many buffers are full? Initially, this counter value is set to 1. And whenever the producer has produced one item, then counter value will be incremented by 1. And whenever the consumer has consumed the item, then counter value will be decremented by 1. So after producing the data, counter value will be incremented by 1. After consuming the data, counter value will be decremented by 1. Because if there are three items, after consuming one item, how many are there? Remaining 2. So 3 minus 1. One data we have consumed. How many are there? 2 items are there. So that's why the counter value is decremented by 1 after consuming every value. So using this variable, we can modify the code for producer and consumer process. So see the modified code for producer and consumer process. So while true, so while counter equal to buffer size. So counter equal to buffer size. For example, if the buffer size is 3, if the buffer size is 3 and counter equal to 3, so what is meant by the counter variable? Generally, how many buffers are full? So here if counter value 3, so 3 means what is the total size of the number of the buffers? 3. So 3 equal to 3. Counter equal to buffer size. 3 equal to 3. So all buffers are full. If all buffers are full, then producer cannot produce the data. So if it is not equal, counter not equal to buffer size, then producer can produce the item at IN location in the array buffer. After producing the one item, IN value will be incremented by 1. So this is the another modified code for producer process using a counter variable. And next we'll see the modified code for consumer process. while true, while counter equal to 0. So counter means how many buffers are full, how many are full. So for example, if counter variable equal to 0, so how many number of the buffers are full? 0 buffers are full. So 0 buffers are full means the buffers are empty. So there is no data to be consumed. So consumer cannot consume the data. So nothing will be done. So consumer can be terminated. So nothing will be done. Otherwise, if it is not equal to 0, counter not equal to 0 is nothing but there is at least one buffer for consuming the data. Then we can consume the data from the out location, from the buffer full, and it will be stored in the consumed variable. After consuming the data, out value will be incremented by 1 and automatically the counter value will be decremented by 1 because the consumer has consumed one data. After consuming one data, how many remaining to be consumed? -1. So that's why the counter value will be decremented by 1. So this is the modified code for consumer process using counter variable. So thank you for watching the video. In the next video, we'll discuss about another IPC mechanism, that is message passing. Thank you for watching the video.